Hi everyone, this video addresses question 2 in the practice section of 6.1, Continuous Probability Distributions. The question reads, the commuter trains on the red line for the Regional Transit Authority in Cleveland, Ohio have a waiting time during rush hour periods of 8 minutes. The first question that we want to address here is what the random variable is. We're able to pull this directly out of the narrative, so our random variable that we will eventually use is going to describe the waiting time during rush hour periods. Usually the random variable we use is going to be x, but you absolutely could use something else. So you could use w to represent waiting or t for time. X is kind of the default when in doubt. So we're just going to say x is going to be waiting time during rush hour periods. So we're just looking for that general description. We don't have to have the numerical portion within there. That's actually going to come into play for part B. So the next thing we want to do is find the height of the distribution. So we're going to go ahead and we're going to create an x and a y axis. And what we want to note here is we have waiting times going up to 8 minutes. They don't provide you a range here, so they're not saying that you're going to wait between 3 and 8 minutes. So since they haven't provided us, for lack of a better term, a lower bound, we're going to assume that that lower bound here is 0. So there would be a 0-minute waiting time. You might be lucky, just as you are entering the train station, that your train is ready for boarding and is about to go. So we're going to start off by saying you could be waiting 0 minutes. And then you could wait maybe up to anywhere in between 0 and 1 minutes. And of course, since they've called it out and said 8 minutes, that's how far we're going to take that number line on the horizontal axis. So this is the part of the video that is probably a little bit boring because you get to make sure that I know how to count from 0 to 8. All right, so at this point, we want to determine the height. So I'm going to kind of skip ahead here, and I am going to go ahead and create this rectangular shape because we know that we are working with something that is uniformly distributed from this section. What we want to remember about distributions is the area under the curve represents 100%, or in this situation, we might want to work with its decimal version. So the decimal version of 100% is just 1. So we know that the area of this rectangle is 1. So what we're going to kind of call out here is I know that the length of this is going to be 8 units. And I know that the entire area is going to be equal to 1. So we can kind of pull back what we remember from geometry, and we can note that area is equal to that length times height. So again, we're going to just start dropping things in. So I know that the area is 1. I know that my length is 8. And at this point, I'm claiming that I don't know what the height is. But now that I've kind of created this equation, well, not kind of, I have created it, we are able to solve for that variable x, which is our height. So I am going to go ahead and divide both sides by 8 in order to undo that multiplication between our number 8 and our variable x. So this tells me that my height is 1/8. And again, you can check this. So if you did 1/8 times 8, that does give you an area of 1. And you can use this when you are working with uniform distributions at all times. So if you know the length of your distribution, you automatically can note what the height of that distribution should be. It's just going to be the reciprocal. So for example, maybe we went to, I don't know, a different city. Let's just say you went to I don't know, Orlando or something like that. And they said that you have only up to a 4-minute waiting time to use their train. So that would mean that we would be waiting anywhere between 0 and 4 minutes which means that we have a length of 4 for our uniform distribution. We are going to assume that it's a uniform distribution. So the height must be 1/4, because again, 4 times 1/4 would give me that area of 1. So let's go ahead and apply this to the next portion of this problem. So for part C, we want to find the probability of waiting between 4 and 5 minutes. So again, we are going to use the distribution, the uniform distribution that we sketched out in part B. We know that the entire area underneath that blue rectangle is equal to 1. Our goal is we want to find what portion of this area falls between 4 and 5 minutes. So this decimal or this fraction that we are creating is also representing the probability of having to wait between 4 and 5 minutes. So I'm going to go ahead and not erase my drawing here, but I am going to go ahead and just sketch out or look at that shaded area. So I want to know, out of this entire area of 1, how big is that bolded blue chunk? Essentially what we are going to do is we are going to find that area. So again, we know that the height that we see on this smaller blue rectangle is going to be 1/8, and we are now looking at a length of just 1. So in this situation, we would say the probability that our x value is between 4 and 5 minutes is going to be equal to my length, which is 1, times my height. So my probability here is 1/8. Or we could say the decimal form, which is 0.125, or we could do the percentage form, which would be 12.5%. For the next one, for part D, find the probability of waiting between 3 and 8 minutes. It's going to be more of the same. So again, we are working with our entire area going from 0 to 8 minutes. That has the area of 1, or 100%. We are now going to look and see what portion or what percentage falls underneath the curve between 3 and 8. Sorry, that coloring looks really terrible, but hopefully you're not here for the visual effects. So again, we are going to take a look at the area here. So I know that the height of this bolded blue area that I'm looking at is going to be 1/8, because it's a uniform distribution, so the height never changes. And now the length is going to go from 3 to 8, so we have a length of 5. So again, using our probability notation, we're going to say the probability that x is in between 3 and 8 is going to be 1/8 times 5. So we can say that that is 5/8. Or in other words, 0.625. Or in other words, 62.5%. All right, we've got one more. For part E, we want to find the probability of waiting 5 minutes exactly. So notice now we are not working with a range of time. The last two we're looking at waiting between 4 and 5 minutes, and the other one was between 3 and 8. This time I'm just giving you one number, and I'm really making it a hard set number by using the word exactly here. So if we were to draw that into our distribution, we would note that it's just going to, again, not erase the line, draw the line. It's just going to be a single line that we have in here. I'm not shading anything to the left, because if I shade everything to the left, then that means what's the probability of waiting between 0 and 5 minutes, and I'm not going to shade anything to the right, because then that would mean waiting between 5 and 8 minutes. We are just looking at the probability of waiting exactly 5 minutes. So the trick here is, we do note that the height is 1/8, but what's the width of a single line? Well, the width of a single line would just be 0. So when we look at this and we say the probability of our waiting time being exactly 5 minutes, we are doing 1/8 times 0. So in other words, the probability is 0.